Okay, so let's start with another very useful algorithm that is known as market basket analysis. And this exercise we are doing for the retail outlet. So let's see, and we are using a retail outlet data also. So let's clear the output first, and then we will start our activity, our exercise. So all this has been cleared now. Now this market basket analysis with ML extend. We are using another very important library known as ML extend, and this library you have to install. So you have to, for installing that, you have to use that pip command, that is pip install pandas ML extend, right, as it is mentioned. Other things are again common, that market basket analysis with retail data, and to get started we'll need to have some ML extend installed, and this is how we can install, right? Import pandas as PD. From ML extend frequent patterns, import a priori. From this library also you can have some sub libraries as it is mentioned. Then ML extend frequent patterns, import association rule. Now this association rules will tell you that how the two or more items are related. When somebody buys item A, he may also buy item B, because that is associated, like bread and butter. So likewise there are so many items which are likely to be bought by the customer simultaneously at the same time. That is quite common. Then we are also using this data set which is available, and it is like retail underscore ol means online.csv. it is a csv file. Encoding is Latin 1, and then low memory, false. So this is only to take care of any kind of a problem in the data set. So that is why this additional precaution has been taken, additional code has been written. And low memory means that in case, because the data set is quite big, so in case there is a problem of memory shortage, then that can also be taken care of. So that is how we can do that. So we can run this, we can run this also, right? Then we can go import our data file also, because that is required. So let that be over, then we'll come to this. We can run this also. Yeah. So this installation of any extra library you can use within the body of the program also, or maybe you can install it separately just by going to the command prompt, and then you can install it. So either way this can be done. So since we have already done it, it is giving all these messages. It is not required, but yes, fine. Then we have imported other libraries also. Then we are importing the data file as it is shown here. Then further on to this, you can see that Latin 1, if you see this one, this is also called ISO 88591. This is just for your information, and you must be knowing about it. It is an 8-bit character set endorsed by the International Organization for Standardization, ISO, and it represents the alphabets of Western European languages. Because this data comes from Europe, so it is quite likely that they might have used some European say characters. So just to safeguard that, this has been done. As its name implies, it is a subset of ISO 8859, which includes several other related sets for writing system like Cyrillic, Hebrew, and Arabic. It is used by most Unix systems as well as Windows, DOS, and Mac. However, use their own data sets, right? So it is not mandatory, but it is always better to take care of such thing. In Latin 1 is also occasionally, though imprecisely, referred to as extended ASCII. All of you must be familiar about the ASCII. So this is because the first 128 characters of its set are identical to the US ASCII standard. The remainder of this set contains accented characters and symbols. A table describing the Latin 1 character set is available on Google also. So the first table contains characters that may not be valid or correctly displayable for all fonts, platforms, and browsers. The second table provides descriptions for these characters as well as the set's non-printing character. So this is just for your information and knowledge, so that you as a developer you must know about these things, and in case it is required you can use it. Now we are going to print our top 5 records as it is shown here. It is having the invoice head, stock code, description, etc., etc. All these things are visible, so we can have a feel of the data. Then we are going to check the shape of the data, that also we can get. We are having this particular data set is having 5,41,909 rows and 8 columns, right? Then we are having some more information about the data, that is info that we have got here, that is all those variables which are there, and then the total number of rows, etc. Then the type of data, that is object, float, 64, and like that. Then we are going to have the description of the data, that is statistical information, count, mean, standard deviation, minimum, maximum, all these things are available in this, right? Then we are also going to have the data types, that we have already seen, but we just this code gives you the details of the data set type only, right? Then there is a little cleanup we need to do. First, some of the descriptions have spaces that need to be removed. Will you also drop the rows that don't have invoice numbers and remove the credit transactions? Now this is something which is required so that your data becomes perfect. If there is any problem like that, the results may not be proper. So that is why it is always recommended that you must clean up and make your data as perfect as possible. So we can run this, and then we can see, nothing will happen, but definitely this is a step. And to do that, this is the way we can do that. That is df description string, and then strip, and then drop NA. Axis 0, subset is invoice number. In case there is no invoice number available, drop that, right? And in place it is true. So that is what it is going to do. Then df invoice number as type string. Now if that is possible, then that can be also done. And then df invoice number string contains C. So that can be done. So once, if it is not there, it is not mandatory, but you must take care of every eventuality, every possibility. So we can run this, and this process has been completed. Now after the cleanup, we need to consolidate the items into one transaction per row, with each product one hot encoded. For the sake of keeping the data set small, I am looking for sales for France. However, in additional code below, I will compare these results to sales from Germany. Further country comparisons could be interesting to investigate. So let's do this. Now basket df country is equal to France, then group by invoice number, description, quantity, sum, unstack, reset index, and fill NA. Right? If it is not applicable, then you can write it 0. Then set index, invoice number. Right? This is the way you can write the code, so that you get, this is no output will be there, but certainly the process has been done. Here what the first few columns look like. Note I added that some numbers to the columns to illustrate the concept. The actual data in this example is all zeros. So we can run that also. Nothing will happen here, but then basket head, that you can see, and you will see that now you are getting all the those top 5, because we have got the basket dot head. So top 5 rows will be printed here along with the invoice number and all those details. Then we are having 5 rows and 1, 5, 6, 3 columns, right? Is it huge? Then there are a lot of zeros in the data, but we also need to make sure any positive values are converted to a 1, and anything less than 0 is set to 0. This step will complete one of the hot encoding of the data and remove the postage column, since that change is not one we wish to explore. So we can run this. This is again for our understanding. Then we are going to write this code for def encode units x. If x is less than 0, return 0. If x is greater than 1, return 1. Right? Simple code. Then basket sets, basket apply map and encode units. then basket set drop postage in place 2 and axis 1. So this is the way you can drop in case it is mentioned as postage. So you can run this, and again no output will be there, but then it has done its job. Now that the data is structured properly, we can generate frequent item sets that have the support of at least 7%. This number was chosen so that one can get enough useful examples. So frequent item sets is equal to a priori basket sets, minimum support is equal to, that is why this 7% means 0.07. Use column names true. So we can again run this, again nothing, no output will be there, but yes, it has again done its process. Then the final step is to generate the rules with their corresponding support, confidence and lift. Rules is equal to association rules, we have mentioned in the beginning. Then frequent item sets, metric is equal to lift, and minimum threshold is 1. So at least one item should be there along with the first item. And rules head. So then if you run it, you can see that we are getting the antecedent, that means the first thing, or maybe and here in this case it may be an alarm clock, bark line, bake like green, or whatever color, etc. These are the details. Consequence after this, what is there? That is the consequent. And antecedent support, that is what the support is, and then consequent support. You see, each and everything has been given in detail. And support, then confidence, lift means that how many has been taken by the customer or the person who wants to buy, then leverage, and then the conviction. So all such details which you need for your analysis, you are going to get it. Then that's all that there is to it. And build the frequent items using a priori, then build the rules with association rules. Now the tricky part is figuring out that what this tells us. For instance, we can see that there are quite a few rules with a high lift value, which means that it occurs more frequently than would be expected given the number of transactions and product combination. We can also see several where the confidence is high as well. This part of analysis is where the domain knowledge will come in handy. So therefore, it is very important that the person who is doing this analysis must have the knowledge of that particular domain on which he is working. Since I do not have that, I'll just look for a couple of illustrative examples. So quite likely as a developer, you may not have the knowledge of every domain. So still you can do that by understanding. You have to do it repetitively, and then you can understand it. So we can filter the data frame using standard pandas code. In this case, look for a large lift 6 and high confidence 0.8. So this is just for our understanding, so that how this is done. Then rules. This is the way the code is written, that rules lift greater than 6 and rules confidence greater than 0.8, right? Because these are the two things, if you remember, we have mentioned in the beginning that 6 and 8, right? So that is how we have to write the code here, and we can run this. So once we run this, then you are getting these details, right? Now you are getting in tabular form, you are getting all this. Now in looking for the rules, it seems that the green and the red alarm clocks are purchased together. Now this is the association rules. That means now you can see in your output also that the green and the red alarm clock are being bought separately. This is antecedent, that means the first buy, and then this is the second buy. So that is how the association rules are generally made. And at this point you may want to look at how much opportunity is there to use the popularity of one product to drive sales of another. Now this is where your marketing expertise comes into play, that how to put the items together so that when a person is buying one item, the associated item can also be bought by the customer. For instance, we can see that we sell 340 green alarm clocks but only 316 red alarm clocks. So maybe we can drive more red alarm clocks sales through recommendations, right? So this is why this type of things do happen, and this is the marketing strategy. This is how we can sell more, and those items which are not selling much, you can sell it this way. Now the code for again this alarm clock for the green color, that is basket alarm clock bake like green, sum 340, and basket alarm clock bake like red, sum which is 316. So we can run it, and then you can see that it is still we are getting 316. Now what is also interesting is to see how the combination vary by country. Now this is also something which you can infer from the data itself, from the output itself, that it is not that the same thing is getting sold in every country. It is country specific. From country A to country B, it is not the same, it is different. So what is also interesting is to see how combination vary by country of purchase. Let's check what some popular combination might be in the Germany, right? Now for that we have written this code like basket 2 df country is equal to Germany, group by invoice number, description, quantity, sum, and then unstack, reset index, and fill NA, then set index, invoice number, and then next is basket set S2 basket 2 apply map and code units, basket sets 2 drop postage, in place true, access 1. This again, if you remember, we have written this earlier also. And now frequent item set 2 a priori basket sets 2 minimum support is equal to 0.05, use column names true, and then rules to association rules. It's similar code you can see, but yes, now we have to do it with a different condition. So frequent item set metric lift and minimum threshold is 1, right? That means minimum 1 is to be taken. That is of course the condition. The rules 2 lift is equal to greater than 4, and rules 2 confidence is equal to 0.5. So this is how. So you can definitely think about it, that what kind of a condition we should put in so that we get our job done. So when we do this, you can see that and after completing this process, you can see that now antecedent is again plasters in the circus parade, then plasters in tin woodland animals, all these things. So association can easily be established, and this of course, because you are in this line, you are a marketing expert, you definitely you suggest the developer or the analyst that this is the type of analysis that you are looking for. So you can see that all such things are easily understood by the concerned person who wants to do this kind of analysis. So this really the really nice aspect of association analysis is that it is easy to run and relatively easy to interpret. MLXtent is very useful in this type of association analysis. Otherwise it would be difficult to find these patterns with MLXtent. So the analysis process is relatively straightforward, and this has been possible, this has made possible because of the MLXtent. So that is how you can do this kind of analysis for the market basket analysis, which is very, very useful. Thank you.